In the heart of Starbase, Texas, a gleaming marvel of engineering reaches toward the stars. Starship, not just another rocket, but a vessel that's challenging everything we thought we knew about space exploration. While some skeptics questioned its ambitious design, Planetary scientists working directly with the project are now stepping forward with extraordinary revelations about its capabilities. Dr. Jennifer Heldman, a leading planetary scientist, puts it into perspective. You can really take advantage of the Starship architecture and get to the outer solar systems in ways we haven't thought about before. She's not alone. From veteran Apollo scientists to cutting-edge researchers, experts are drawing parallels between Starship's potential and humanity's greatest space achievements. This isn't just about reaching Mars anymore. From defending Earth against asteroids to establishing lunar bases and exploring the mysterious moons of Jupiter and Saturn, Starship is opening doors we once thought were decades away from being unlocked. Through groundbreaking engineering and innovative design choices, SpaceX has created a vehicle that's redefining what's possible in space exploration. Today, we're going to explore the remarkable features that make Starship so far ahead of its time, and why scientists around the world are calling it a turning point in human spaceflight. This is Elon Musk 24 Hours, and let's dive right in. When Elon Musk first unveiled his vision for Starship, many saw it as just another rocket. Perhaps bigger, perhaps more ambitious, but still fundamentally similar to what came before. They couldn't have been more wrong. As we dig deeper into what planetary scientists have discovered about Starship's capabilities, we're uncovering a story that goes far beyond conventional space exploration. Standing on the factory floor of SpaceX, veteran Apollo scientist James Head felt something he hadn't experienced in over half a century. Being on the floor of the SpaceX factory is the closest I've felt to having been in the Apollo program, he revealed. This wasn't just nostalgia speaking, it was recognition of a fundamental shift in how humanity approaches space exploration. Consider this. While conventional rockets struggle to lift a few tons into orbit, Starship is already demonstrating capabilities that dwarf everything that came before. During Flight 7, it successfully carried payload mass equivalent to an entire Falcon 9's capacity, and that's just the beginning. SpaceX engineers are working towards a version 3 that could transport over 200 tons per launch, a capacity that would transform every aspect of space exploration. But raw lifting power is only part of the story. Dr. Margarita Marinova, who spent years as a senior Mars development engineer at SpaceX, points to a more profound revolution. It'll be a really drastic change in how we do science. She's talking about the way Starship's massive payload capacity will transform our ability to conduct research beyond Earth. Instead of carefully miniaturizing every instrument to fit within tight mass constraints, scientists can now dream bigger, much bigger. Take the case of planetary defense. Dr. Philip Lubin from UC Santa Barbara has proposed something that would have seemed like science fiction just years ago, using Starship to protect Earth from extinction-level asteroid threats. His team has calculated that Starship's unprecedented payload capacity could deliver enough defensive capability to deflect or destroy asteroids up to 10 kilometers in size, the same class as the one that ended the dinosaurs' reign. This isn't just theoretical. They're already looking at potential test missions targeting Apophis, an asteroid set to pass close to Earth in 2029. But perhaps even more intriguing are the possibilities for deep space exploration. A group of international scientists known as KEX has developed a mission concept called Arcanum that would use Starship to explore Neptune and its mysterious moon Triton, a destination we've only glimpsed once through Voyager 2's brief flyby. Nobody's really thinking on this next level about what Starship could enable, says James McVitt, the KEX team leader. The mission would revolutionize our understanding of the outer solar system's dynamics. The revolution extends closer to home as well. In the coming years, SpaceX plans to achieve something unprecedented, launching Starship up to 25 times from Starbase in 2025 alone, with a target of 400 missions over the following 4 years. This isn't just about frequency, it's about redefining what's possible. The goal is to develop boosters that can be reused hourly and Starships that can fly daily, bringing the cost per launch down to an astounding $2 million. To put this in perspective, NASA's Space Launch System costs approximately $4 billion per launch. That's not a typo. Starship aims to be 2,000 times more cost-effective. This dramatic reduction in launch costs could democratize space access in ways we've only dreamed about. The implications for Mars exploration are particularly profound. With 10 Starship flights per day, each carrying over 200 tons, SpaceX could deliver 1 million tons of materials to Mars in just 8 years. That's enough to establish a self-sustaining city on another planet. Starship can bring unprecedented amounts of payload to Mars and elsewhere, emphasizes Dr. Jennifer Heldman. Planetary scientists need to be thinking about how we can take advantage of this capability because it's extraordinary. The versatility of Starship's design opens up even more possibilities. SpaceX is exploring ways to transform these vessels into modular space stations, creating a network of interconnected habitats in Earth orbit. This approach could revolutionize how we construct orbital research facilities, slashing both costs and construction times. The same principles could be applied to establishing lunar outposts, offering a simpler and more efficient alternative to NASA's complex Gateway project. Scientists from the Max Planck Institute, led by Renee Heller, are already planning missions that would use Starship's capabilities in innovative ways. They've proposed using Mars as a stepping stone for missions to Jupiter, pushing the boundaries of what we thought possible in solar system exploration. We should be able to follow its acceleration and path through the solar system for a few days and almost to the orbit of Jupiter, Heller explains, highlighting how Starship could open up new frontiers in space science. The timeline for these advancements is accelerating. Flight 8 is targeting the first fully reusable Starship mission, with the goal of mastering this capability by 2025. Unlike its competitors, which have faced frequent delays and setbacks, Starship's development has been marked by steady progress, with challenges coming primarily from regulatory hurdles rather than technical limitations. What makes this particularly remarkable is that all of this is happening not in some distant future, but right now. Scientists and engineers are already preparing payloads and experiments for upcoming Starship missions. They're not just planning for what might be possible, they're actively working to make it happen. This unprecedented combination of payload capacity, reusability, and rapid development is reshaping our approach to space exploration. We're moving from an era where space missions were rare, expensive endeavors to one where regular flights to Mars, the outer planets, and beyond become routine operations. The implications for scientific discovery, technological advancement, and humanity's future in space are profound and far-reaching. As we continue to see Starship's capabilities expand and evolve, one thing becomes increasingly clear. We're not just watching the development of a new rocket, we're witnessing the birth of a new era in human space exploration. The scientists who have worked directly with Starship aren't just optimistic about its potential. They're actively preparing for a future where the solar system becomes our backyard. This is Elon Musk 24 Hours, bringing you the latest insights into how Starship is revolutionizing our journey to the stars. Let's dive deeper into the technical details that make all of this possible. The story of Starship isn't just about revolutionary technology or unprecedented capabilities. It's about expanding the horizons of human achievement, from its potential to protect Earth from asteroid threats to enabling cities on Mars, from transforming space stations to exploring the outer reaches of our solar system. Starship represents a pivotal moment in our journey to the stars. As Dr. Jennifer Heldman reminded us, the time to prepare for these extraordinary opportunities is now. Scientists worldwide are already developing experiments and missions that will leverage Starship's groundbreaking capabilities. With each successful flight, we move closer to a future where space exploration becomes more accessible, more frequent, and more ambitious than ever before. What aspect of Starship's potential excites you the most? Is it the possibility of establishing human settlements on Mars? The prospect of exploring Jupiter's mysterious moons? Or perhaps its role in defending our planet? Share your thoughts in the comments below. If you want to stay updated on the latest developments in Starship's journey and other groundbreaking space technologies, make sure to subscribe to Elon Musk 24 Hours and hit that notification bell. Your support helps us continue bringing you in-depth coverage of humanity's next giant leap into space. This is Elon Musk 24 Hours, and we'll see you in the next episode. 7 seconds of triumph, followed by an unexpected turn of events. While the world watched Ship 33's dramatic finale, another story was unfolding right back at Starbase, one that would prove just as crucial to the future of spaceflight. On January 16, 2025, Booster 14 made history as it gracefully descended toward the launch tower at Boca Chica. The mechanical arms reached out, executing a precise choreography of engineering that would mark only the second successful catch in Starship's history. But beneath this achievement lies a complex web of challenges that few have stopped to examine. From an engine that initially refused to light, to subtle signs of structural stress that emerged in the aftermath, Booster 14's journey tells a story of both breakthrough and concern, one that deserves our full attention. Welcome to Elon Musk 24 Hours, and today we're pulling back the curtain on what really happened with Booster 14 during Flight 7, before, during, and after its historic catch. The answers might surprise you. Let's dive right in. The mechanical arms of the launch tower stood ready in the Texas dawn, awaiting a reunion with their massive metal dance partner. Booster 14's return to Earth would mark only the second time in history that SpaceX attempted this precise aerial ballet, a 230-foot-tall rocket gracefully descending into the waiting arms of Mechazilla. But before we delve into those crucial final moments, let's trace back to what made this flight different. As Booster 14 lifted off from Starbase that January morning, the SpaceX team knew they were pushing boundaries. The previous success with Booster 12 during Flight 5 had given them confidence. But space exploration never guarantees an encore performance. The first sign that Booster 14 would write its own unique story came during the boost-back phase. As the massive first stage began its calculated return, one of its Raptor engines refused to wake from its brief slumber. In the world of rocket science, where millisecond timing and perfect synchronization reign supreme, this momentary hesitation sent ripples through mission control. The engine eventually roared to life during the landing burn, but this early stumble raised critical questions about the complex dance between hardware and software. Think about the sheer audacity of what SpaceX is attempting here. Each Raptor engine is a marvel of engineering, pushing the boundaries of what's possible with methane propulsion. When one of these powerhouses shows even the slightest hesitation, it's like a prima ballerina missing a step in a perfectly choreographed performance. The implications stretch far beyond this single flight. They touch the very heart of SpaceX's vision for rapid reusability. The engine anomaly wasn't just a technical hiccup, it was a window into the countless variables SpaceX must master. Every sensor reading, every line of code, every mechanical movement must work in perfect harmony. The team's ability to adapt and compensate for this unexpected behavior showcases the robust design philosophy that's become a hallmark of the Starship program. As Booster 14 continued its descent, eagle-eyed observers noticed something else, a subtle but concerning detail in the engine section. Photos captured what appeared to be warping during the relight phase. While heat distortion from camera angles might explain these images, they sparked intense debate within the space community. Was this a sign of structural stress? A new challenge for the engineering team to overcome. The real drama peaked during the catch attempt. Unlike its predecessor, Booster 12, Booster 14 exhibited increased oscillation after being secured by the chopstick arms. This wasn't just a subtle vibration. It was a visible reminder of the immense forces at play. The tower's arms, designed to cradle a rocket weighing as much as a small passenger aircraft, had to maintain their grip while compensating for these unexpected movements. But there's more to this story than just the technical challenges. Behind every decision, every adjustment, stands a team of dedicated engineers and technicians. They've poured countless hours into understanding these systems, anticipating failure modes, and building redundancies. When reports emerged of catch ramps showing signs of wear, it wasn't just about replacing hardware, it was about understanding the complex interaction between materials under extreme stress. The catch mechanism itself represents one of the most ambitious aspects of the Starship program. It's a testament to human ingenuity that we've reached a point where catching a rocket has become a realistic goal. But success brings its own challenges. The software controlling this operation processes thousands of data points in real time, making split-second decisions that mean the difference between triumph and disaster. What's particularly fascinating is how SpaceX balances automation with human oversight. Even with all the advanced algorithms and sensors, a flight director must still give the final go-ahead for the catch attempt. This hybrid approach speaks to the wisdom gained from